Hello, welcome to another edition of Java Programming. This is Owen Riley again, and today we're going to talk about Java exceptions. We see here in front of us a hierarchy tree starting at the very top. Now remember, all things in Java extend from the object class, and when we talk about exceptions, we're talking about the throwable class. Throwable extends object. As I say, everything in Java extends object for our purposes. So when we talk about where do all Java exceptions extend, they all extend throwable. It would be incorrect to say all Java exceptions extend object because that's too generic of a statement. As I say, all classes in Java extend object. So we're specifically saying exception class and error class extend the throwable class. Throwable, in Java we say errors are thrown, and you have to catch thrown errors or thrown exceptions. Errors are things that if they are thrown, they will cause the Java virtual machine to crash, and there's nothing the programmer can do about that if an error is thrown. A programmer can cause some of these things to happen, but if this happens, the Java virtual machine will crash. On the other hand, exceptions can be caught. Thrown exceptions can be caught. Thrown errors cannot. They will cause the machine to fail. But exceptions is what we're talking about, and we are in our lecture here in our world this week talking about runtime exceptions. And you can see runtime exceptions are extended through some various other exceptions, and this is just a partial list. I'm going to show you a more complete list in just a second. So this is just kind of a good UML diagram, a partial listing of the UML diagram for the Java throwable class, if you will. On my next page here, I've got a little bit more detailed. Notice that these are both in the java.lang folder. That also means that all of these things are by default available to your program. You don't have to import anything special when you're using classes from the .lang folder. And these are our exceptions. This is what we're going to worry about. And you can see these are the 7 different exceptions here. And again, what we're worried about is the runtime exceptions. And you can see these are the various runtime exceptions that are defined. And when I say defined exceptions, that means there are classes called index out of bounds exception, public class negative array size exception, things like that. Furthermore, the index out of bounds exception, notice it's extended even further to the array index out of bounds exception and the string index out of bounds exception. Our illegal argument exception is also extended. And again, these are in the .lang folder. These are the runtime exceptions. These can be caught by the programmer and that will allow your program to continue to execute. On the next page, we see a more complete listing of the errors in the throwable class. And like I say, they are unrecoverable in a way, and it even says thread death. So there are things that might happen that you don't want to have happen if an error is thrown, but a lot of times we can't do anything about that. Not from our programming point of view, not from the programming we're studying and learning here. And again, these are errors. They are thrown in the .lang folder, but we're not going to catch these ones. They'll get past us. It's like a fastball in the dirt. It's going to get past us. Okay, let's look at some examples now. Let's go all the way back to the early days of your Java programming careers. Here's a nice simple example. Now you notice in past lectures I've created folders with the code in it, and this week that's not going to be the case because all of our code fits for each of our classes easily fits on one screen, 2 at the most. So you can easily take a screenshot and then enter this code in as you get a chance to. And remember, that's how we want you to do it. Always enter the code. That's really part of the learning process. Well, let's just see what we've done. Notice we have the scanner out of the utility folder. We had to import that. If the scanner was in the .lang folder, we wouldn't have had to import it. But now you understand maybe a little bit more. Anything in the utility folder, we will have to import if we want to use it. And there's a lot of things in there. And as I say, you could always use that dot operator. Let me pause just for a second and bring my dot operator into play. And these are all things that are available in that utility folder lots and lots and lots of different things that we just can't get into in a class like this. You've got to just understand them as you come across them in your work environment or study more on your own. And you can see one of the ones we want is that scanner. I just saw it here a second ago. That's the one we're going to use today. Okay. But we don't need to say anything else about that. Here we create our object of my scanner. Now we're going to create an array of strings that we'll call vowels. We'll use an initializer list to use A, E, I, O, and U, not Y today. We're just going with those 5. We'll have a little prompt, system.out.println, please enter integer less than 5. We'll input our data. We'll try to read an integer, put it into an integer called number 0, 1. And then we will say down here, system.out.println, your vowel is vowel subscripted by number 1. We'll kind of translate the user's input. If the user puts in a number less than 5, everything is great, nothing goes wrong, and we're happy as a clam. Let's see what happens. I'm going to run my program. Please enter an integer less than 5. I'll put in 3. It says my vowel is O. Spot 0, 1, 2, and 3. By George, it's right. My vowel was O. No problem there at all. Let's say my user misunderstands. It says please enter an integer less than 5. Maybe they understand, but they just fat finger it and put in a 0 this time instead of an O. Boom, what happens? The program abnormally ends. It crashes, in other words. This is your stack trace. We talked about that before, a stack trace. It shows up when your program crashes, when the machine can't handle it anymore. And the first line up here is going to tell you what happened. It encountered in the main thread, which is the only one we got working here, the main method, it encountered an input mismatch exception. And that error was thrown in this method, and this is what preceded it. And we want to find, in this stack trace, we want to find the first reading down, the first reference to our program. Well, the first reference to our program here is on line 10. And it says this line 10 caused that input mismatch. And they're right. I put in an O, letter O, instead of a 0, and that's what happens. But let's say my user doesn't quite understand, and they read it, please enter an integer greater than 5. Maybe they don't know their symbols real well, and they misread that, and they put in a 6. Boom, we crash again. This time we crash with an array index out of bounds exception. Notice which folder that's in. That's in the .lang folder. And again, this is our stack trace. It's a shorter stack trace this time, but it started in line 11, and that's when it tried to translate that integer 6 into a index for my array, and it could not do it, so it threw the array index out of bounds exception. Again, notice that's in the .lang folder. Let me run this one more time. Notice again, if I put in the O, letter O, this is in the java.util folder. Keep that in mind in just a moment as we go on. So this is what happened. We encountered this back in Java 1, probably by week 4. Excuse me. Let's look at a second example. We learned how to catch these errors so that they wouldn't cause our program to crash. Now, if you're entering these from scratch, what I would do is I would copy this first class, just copy that in the Java, in the Eclipse, just tell it to copy and paste and give it a new name, call it a Java Exceptions 02, and then make these slight changes. Because the only changes between the first example and this second example is the addition of the try catch. Remember, we learned that if the user can catch errors that are thrown, the program won't abnormally end, and it will end in what we consider to be a more elegant manner. So let's see what's going to happen here. This time I'm going to try to set up this array, and if this array can't be set up, an error will be thrown, and I can't handle that, remember. Because I can't handle errors, I can only handle exceptions. This will throw an exception if I don't give it a good integer. This will throw an exception if I don't give it a good array index out less than 5. And notice, since both of these are going to throw two different errors, I'm just catching this generic exception, and I'm putting in this temporary argument, this EX. Remember, I'm creating an EX of type exception here. That's how we read these parameter lists. And I'm just simply going to say this: you did not enter an integer, even though that might not be true. As we've seen, both zeros and sixes will throw errors. So let's run this one and see what happens. First, let's give it a good number, make sure it works. I put in a 4 and it says my vowel is U. Perfect. Let me run it again. Please enter an integer less than 5. Well, how about if I put in a 6? This time it says you did not enter an integer, and oh, I got to put a space there. Java.lang.array index out of bounds exception inline 6. So you'd go back up to, oh, excuse me, not inline 6. This is the value you put in, you entered a 6. So that means notice my program didn't crash this time. It gave me my message and then stopped. There's no stack trace here. Let me run it again, and that is a good message. Except notice I did enter an integer, and it says I did not enter an integer. Let me get rid of my, I need to add a space there. There we go. Let me run it again. This time I'm going to put in the letter O again. This time it says you did not enter an integer, java.util.input mismatch exception. Well, that's true. I had an input mismatch from this utility folder, but my message is wrong. Oh, my message is right. It says you did not enter an integer. I keep mixing those up, don't I? You did not enter an integer. When I run it the first time, if I enter a 7, I did enter an integer, and I get the right error message, but the wrong message here. And that's because I caught this generic exception. And we don't want to catch generic exceptions anymore. For Java 1, that was fine, as we just learned it. But now we want to be more sophisticated, and we want to catch more specific errors. And we want to be able to catch both of these errors separately and give specific messages for them. So to do that, guess what? We'll come up with a third example. So again, copy this one in your tree, right click it and tell it to copy. Go back up to your source, tell it to paste now. As you do that, it will ask you to rename it. If it asks you to save anything, tell it yes. It will ask you to rename it, and you'll just give it the new name of number 3. Here we go. Now notice I got to expand my imports here. Boop. Perfect. Notice I'm going to catch specific imports this time. Everything is the same. All of this is the same in my try. My catch now is different. Now I'm catching specific errors. Input mismatch exception, which notice I had to import because it's in the utility folder, and my index out of bounds exception, which I did not have to import because it's in the language folder. And Eclipse will tell you where they're at. Boop. Will it tell this one? Yeah, java.util right there. And so again, you have to import things from the utility folder. You don't have to import things from the .lang folder. So now let's run this again and see if we can get specific errors for specific exception messages for our specific errors. Let's run it first again in a good fashion. We'll put in a 4, see if that works. There's my value again, looking good. Let's run it again. I'll put in this time a 6. This time it says your integer was too big, so it lets me know I did put in an integer, but it was too big. And there's my error message and my integer. Put in an integer less than 5. Let's go back to that letter O again. I like that one. Of course, my name is Owen. It says you did not enter an integer. Again, a much better error message. I didn't enter an integer, and it gives me this input mismatch exception. Perfect. It's working just the way we want to. So we've shown you a little bit as we go. Last semester, all you had to do was catch generic exceptions. Not anymore. We never want to see this when you catch things now. If you do, I'll take off for that in the lab because it's not really sophisticated programming practice. We want to catch more specific errors at this point. Now, I'm not going to say you're never going to catch a generic exception, but I'm saying for what we're trying to teach you right now, you need to, from here on out, catch specific exception classes and types. So this caught the input mismatch and it caught the index out of bounds. This one had to be imported from the utility folder. This one did not. Alright, now that's all well and good, but notice our user only got one chance at it. So we taught you another technique, and that was how to force input. So let's look at example number 4, and this one's going to, again, do as before. Copy file 3, paste it in here, and call it file 4. because you're going to find very little changes. This time what we're going to do is we're going to take our entire try catch and enclose it in a do while true. We have the wrong name up there. Again, take your entire try catch that you'll find in number 3 and close it in a do while true. Next, come down here after we translate our vowel, our index to our vowel, and give us a break statement. Remember, the way this works is if this throws an error, we'll catch it and then we'll do it again. If the translation line throws an error, we'll catch it and then we'll do it again. Excuse me. Notice once again, when we try to catch the input mismatch, we've got to clear that input stream so that we don't keep getting into a loop. We'll demonstrate that in a second. Let's run this and see what happens. This time, come on, Eclipse is a little slow catching up to me. Come on, there we go. Please enter an integer less than 5. I'm going to put in an 8. It says your integer was too big. There's my error, there's my number, and it says please enter an integer less than 5. So I'll try again. This time I'll put in my old 0 again, my letter O for 0. You did not enter an integer. Gives me the error, and again prompts me to enter a correct one. This time I'll put in the number 0, hit enter, and I get your vowel is A. That is true. My vowel was A in that 0 spot. Alright, so this is my do while true. This is forcing input, remember. Forcing user input. That's what this technique's called. Notice we've got specific errors. One I had to import and one I didn't. Let's go back once again to our sophisticated tree here. Here is my runtime. These are my runtime exceptions. Notice one of my runtime exceptions was index out of bounds. Index out of bounds. Notice type mismatch is not one of them because it's in a different folder. This is in the java.lang. You can learn much more about any of these if you come to this site here and read up on these. They'll give you much more. Let's see if I can get there right now following my link. Hopefully I can. There, let me move it off there. It's thinking about it. It's thinking about it, but I don't know if it's going to take me. Okay, well, we won't worry about that then. But if you trust me, if you take this link and paste it into a browser, it will work for you. But sometimes, you know, Word's not going to always. Oh, wait, it's still thinking about it. It's still trying. It's still trying. Well, I'm not going to give it too much more time because we got to move on. I knew. Okay, let me X out of that. I think it was going to. Oh, maybe it's going to let me X out. Maybe not. We'll just put it in the background. Okay. Well, I know it's working on it, but trust me, that link will work. All right, now let's go back to our examples. So this is a good example of how you force input into a certain range, how you catch specific errors rather than generic ones. But remember, both of these errors have already been written by some other programmers long ago and far away. And what we're going to teach you now is how to write your own exception classes. So to write an exception class, it's just simply a class. And let me bring up our next example. I'll run it for you, and I'll show you what we're going to do. Boom. We'll recompile that. It says, please enter an integer greater than 10. It looks a lot like what we have just worked on, but in a real key specific difference. Let's first of all, please enter an integer greater than 10. We'll do that. We'll put in a 12 so it works. And we'll say your input of 12 has been accepted. Thanks for using this software. I always like to test my programs with good data first and then try to blow it up. Please enter an integer greater than 10. How about if I enter A1? It says you must enter integers only, invalid number format. There's my input mismatch, which we've caught before. Remember, that would be the type mismatch. It says please enter an integer greater than 10. How about if I enter a 5? What's it going to give me? This time it says you must enter an integer that is greater than 10. Integer not greater than 10 exception has been thrown, and this is the message that was given. So in other words, a class has been written called integer not greater than 10 exception right here. That's the class. And now this program was able to throw it. So let's see how the program does this, and then we'll get into writing that class. Well, a lot of that's just the verbiage up there to let you know what you're reading. Let me expand my imports. That's always critical. There's the same two imports we've seen a lot here today, the input mismatch exception and the scanner. Don't worry about all this. Here's my scanner. We're going to call it reader this time. We're going to have define a number, an integer, outside my do loop, and we're going to set it equal to 0 to start with, which of course would be invalid input, because my number greater than 10, if I set that to equal to 0, that is not true. That's not a good value. But remember, I use local variables here. I must initialize them before they can be used, and that's just a quirk that you got to make sure you cover. And then I'm going to put this in a big do while, not much bigger than our last example though, really. And this is just our forcing input. Remember, this is forcing the user. This do down to this while is going to force that user to put in what we want, and we're not going to leave until we get what we want, or until they hit Control-Alt-Delete and crash out of my program. But otherwise, they're stuck. They're going to be stuck in this loop until they give me what I need. Alright, so we're going to prompt them inside the try. The prompt should not throw an exception. If it ever throws an error, you'll crash, but it should not throw an exception. And then what we'll do is we'll finally read in my number greater than 10 from the user input, reader.nextInt. And then we'll invoke this method. Notice this is the method invocation. Integer greater than 10 is the name of the method. And we're going to send that as arguments. We're going to send it this string, and we're going to send it the number that they just put in. Now remember, if they don't put in a number, this next int will throw an error. And what's going to happen is if they do put in a good number, then it will come down to this method invocation. If their number that they put in was not greater than 10, then this will throw an error. Okay? And then we can see there, it tells us a little bit about it. Eclipse is so powerful, it knows a lot about what you write. And this is something I wrote. And it says, this method, create and use exceptions example, integer.greater than 10 is the method name, taking a field, a string, whoops, I came off of that, I'm sorry. Taking a field, my field of a string, and my number of an integer, it will throw the integer not greater than 10 exception if it needs to. Okay? So what's going to happen is if that throws an error, we'll catch it right here. Notice we're catching this specific error, this one we're going to write. And we'll print out this error message, just specific again to the problem. We'll print my exception. Remember, that's what they caught, my exception. A lot of times we just see that as EX or E. Also, if the user up here in this line, line 35, if they don't put in a good number, we're going to catch that input mismatch, the specific error, input mismatch, and we'll send out pretty much the same type of message, except it's going to be more specific to the problem that was encountered. Also notice in an input mismatch, we got to clear that input stream. We did not need to clear it up here, but we do need to clear it down here if we have a bad number in it. And we'll do that while true. Once we get out of this do loop, remember the only way to get out of the do loop is to get past both of these lines that might throw those exceptions, and we'll break out of it, and we'll come down here and say your input and whatever you put in has been accepted. We'll meet our edits, and that will end our main method. So let's look at this method here, input integer greater than 10. It's a short one. It's just a little edit. But notice how it's set up. First of all, let's review this. It was invoked from a static method. It was invoked from the main method. It's static method. So since this was invoked from the main method without any object name, it must be declared a public static method, as we've seen before. So we have a public static void method. It's not going to return anything. It might throw something, but it's not going to return anything. And it's integer greater than 10. There's the string that's sent to it, and there's the number that's sent to it. Notice down here it says after the parameter list, it will say throws integer not greater than 10 exception. That's the class. If my number is less than or equal to 10, there's the edit. Then we'll say my field equals my field. Just concatenate this together so that it prints that error message we want. And then we'll say throw new integer not greater than 10 exception. Notice that this is the use of that anonymous inner class again. We're creating a class for temporary use, sending it this is calling the constructor, sending it one string, and we are going to then end this method because there's nothing left in it, and that ends the class. It's that simple. So let me get the whole exception. Well, I can't get the whole driver on one page really because of all that other stuff, but there's the do, while, true, and the main. This is the main parts of the main. I'll take it to the top. There's a do through the try up through 38. Take a screenshot. 5, 4, 3, 2, 1. Okay, I'm going to move now. And now we're at, let's see, how about the try through the end of the main. So we've got some lines repeated up there, so you know where they fit in. Take another screenshot. Bingo. 3, 2, 1. And then we'll show you the integer not greater than 10. Notice it's outside the main method as they have to be. And that ends our tester or our driver. Now we only have one more thing to show you, and since we created a new integer not greater than 10, we better have one, and sure enough we do. So in our default package here, we have one last file to look at in this lecture, and this is the definition of the class integer not greater than 10 exception. You need to write your own exceptions, and what you'll need to do is make sure your exception that you write follows this pattern. Notice that the public class integer not greater than 10 exception extends runtime exception. Extends runtime exception. So we're extending this class right here, just like my index out of bounds extended this class. Okay, so keep that in mind. This is the class you're extending, runtime exception. And then we have a constructor, public integer not greater than 10 exception. This is the default constructor, which by the way we are not using or invoking, but we want one written anyhow. You should always write a default constructor if you write any other constructor. And in here we invoke the super constructor, runtime exception, and sending it this string. So runtime exception has a constructor that takes a single string and will send it that message. But what we want to do is invoke this version of the constructor for integer not greater than 10 exception with this string message, because the string message included the number that the user input. So what we'll do is now we'll invoke that runtime exception, sending it this slightly different string that's more specific to what we the problem we've encountered. So let me run this again and I'll demonstrate this. So when we run this, of course it's going to prompt me. Please enter an integer greater than 10. I put in an 11, and it says your input of 11. Whoops! It says your input of 11 has been accepted. Thank you for using this software, which is what we expect. We know it's working as advertised. I put in a 9, and here it throws a specific. It says your number 9 was not greater than 10. Now take a look at this carefully, because this is calling that second constructor. You must enter an integer that is greater than 10. And the one, this message is from that second constructor. If I come into my tester, and when I invoke this line here, let me copy this line just so we can show you the difference. And I'm going to deactivate the first one, but that's the one I'm going to put back. And let's say I call the generic constructor, the default constructor. Remember, this gave me a specific message. It told me what my number, the number 9 that was input, was bad. But when I run it this other way, let me run it again for us. Whoops. And I put in the same number 9. This time it says you must enter an integer that's greater than 10. It doesn't tell me what I put in. It doesn't echo my input. And so the user doesn't quite understand, and it's a good idea many times for the user to know what they put in so that they can understand what they did wrong. But either way would work. It's just in this example, and notice the program is still active. It's going to stay active until I put in a number greater than 10. How about 13? And it says your input of 13 has been accepted. Now, of course, this will loop through. We got to remember that. If I put in a y, it's going to keep looping, and if I keep putting in y's, it's going to keep looping. If I keep putting in 2's or 3's, it keeps looping. So you can see that input, and it's going to stay there. Force that user to put in a good number. When they finally put in a good one, 78 has been accepted. Thank you for using this software. And finally, the program has stopped. The program has stopped. So that's what we got for you this week. You're going to take this idea and write your own exception class or two and embed it in a little test program to see what you can do with it. So hopefully this review of the Java programming exception ideas have helped you. There's our first one. There's our second one with the addition of the try catch. Specific catches. The third one. Forcing input with specific catches, the fourth one. And then one that will follow what you need to do this week, this create and user example exception. That's the only class that has a main method. That's our driver this week. Okay, that's it from here. I hope this has helped you understand some of this material and understand exceptions a little bit more in depth than maybe you did from the first Java class. So now put your newfound knowledge to work. Have fun on that assignment. Remember, all these labs build. What you do this week is going to build into what we're doing next week as well. So good luck, and remember, if you're having problems, post in the discussion board for quick response. That's it. This is Owen Riley saying we'll see you next time, which hopefully will be the best time. Adios.